So we're looking to find the extrema of this function over the closed interval from -1 to +2. So if I look at this graph that I'm giving you, -1 is there, +2 is there, and we are using a closed interval. Not that that really matters if we're just finding extrema. But we also want to consider the endpoints because we have to talk about not just relative maximum and minimum values. We have to talk about absolute maximum and minimum values. So just by looking at this graph, at -1 I can see that we're way up here somewhere. Okay, so I'm probably going to say that that is going to wind up being my absolute maximum. Then it looks like the graph kind of goes horizontal right here. The question is that an extreme value point? We'll get a critical number here if that goes horizontal because we'll have a slope of 0. But this is not a relative minimum or maximum. So we'll have to learn how to deal with that. Down here, though, this will be a relative minimum. And then over here, this will be a relative maximum, but not an absolute maximum. Make sense? Okay. The big question is, what do we do with that once we get there? So if I want to find the extrema, what do I need to do? Take the derivative. So I get f prime of x equals squared. Is that it? And what do we do? Okay. What? Now we set it equal to 0. There is a GCF here of 2x squared, and I'm left with 2x minus 3 equals 0. So now zero product property, 2x squared equals 0, 2x minus 3 equals 0. I divide both sides by 2, and then I take the square root of both sides, and I get x equals 0. Since I took, technically that would be plus or minus the square root of 0, but that's just 0. So then I add 3 to both sides, and I divide both sides by 2, and I get x equals 3 halves on this one. Okay, now take a look at the graph, and you can see that when x is 0, we do have a horizontal there. When x is 3 halves, does look like about 3 halves, we have that horizontal tangent there as well. Okay, so those are called what? No. Critical numbers. These are critical numbers. Critical numbers are where the graph has some sort of extrema. Okay, now what we need to do is analyze what these things are. Because we're looking at the graph, we know that the graph is showing us what they are, but we need to learn how to do this algebraically without a graph. So we are going to set up a little table of values. We have 0 as a critical number, we have 3 halves as a critical number, but we also have this closed interval right here. So we need to include those values. So I'm going to put -1 over here and 2 over here. Just setting up a table so that I can compare values. Basically what I'm doing here is I'm finding ordered pairs for the original function. So now that we have these x values here, like over here, just to make this really clear, I can make this x and then call this f of x. So now that we have these values, I can substitute them in to the original function to figure out what they are, what those values are. Okay? So I take -1 and plug it in, and I get 1. That would be -1 there. So -1 times -2 would be +2. So now I have 3 plus 1, which is 4. And on the graph, when I'm at -1, it does look like I'm at 4. So that makes sense. I take 0. No. You're not always going to be getting a graph. You're not going to always look at a graph. You need to know how to do this algebraically. Okay? So I take 0, plug it in. Clearly, I just get 1 there. 3 halves is going to be kind of a rough one to work on, but I think we can do it. we have x to the fourth, so 3 halves to the fourth power. That's 3 to the fourth over 2 to the fourth. 3 to the fourth is like 9 times 9, which is 81. So I have 81 over what? So 4 times 4 is 16. Minus 2 times x to the third. So 3 halves to the third, we're looking at 27 over 8. And then we're going to multiply that times 2. So 27 over 4. And then plus 1. So we have 81 sixteenths minus 27 over 4 plus 1. What do we do? Yeah? So I got to multiply 27 times 4. So I'm doing that in my head right now, and I get 108 over 16. So it's 81 minus 108. (81 minus 108), so it's going to be negative. 108 minus 81 is 27. So it's negative 27 sixteenths. But then I got plus 16 sixteenths. So negative 11 sixteenths. Wow. Did you do that on a calculator? Yeah? Well, it's right anyway. 2 plugged in, 2 to the fourth is 16, 2 to the third is 8, times 2 is 16. 16 minus 16 is 0, plus 1 is 1. Okay, so now the question is, if we were looking for, because they didn't specify, it just says find the extrema. We found the critical numbers, and now we have found the extrema. We just need to figure out what they are. We have a positive 4 here. That is going to be an absolute max. So negative 1 comma 4 is an absolute max. It's absolute because over the interval that we're looking at, we calculated all of the critical numbers. We included the closed interval. If it was an open interval, we wouldn't. But we included the closed interval, and this is the biggest number we got. So that makes absolute max. Absolute min would be at 3 halves, comma, negative 11 sixteenths. If they were asking for absolute max or min, that would be those. If they were asking for relative max or min, then this would be a relative minimum. This would be a relative maximum, and you wouldn't know that until you graphed it. This would be a relative maximum, except for if we're dealing with an open interval, and then this would not even be there, this would not even be there, and the only thing we would have is a relative minimum. Because of this right here. This is neither a relative maximum nor a relative minimum. Because nearby, if I'm talking about a relative minimum, it's not, because all I have to do is move slightly this way and it becomes not a minimum anymore, okay? Or I move slightly this way and it becomes not a maximum anymore. So it is going to pay off to graph these, but you're not always going to be given the graph. How did you determine it without a graph? We'll get into that. To answer your question, to determine that without a graph, you would look at the sine of the slope here and the sine of the slope here. The sine of the slope is negative as we approach that number. The sine of the slope here is negative as we approach that number as well. So this is a decreasing function. That's coming up down the road. We will do that. We will eventually learn how to do that in this chapter. Very soon, actually. Okay, any other questions? Okay, find the extrema of that. You have an interval.
Yeah, no, but like the graph.
Okay, we do have a point right here. Yeah. We do have a point, so that is going to be a critical number. Looks like it's at 0. We do have another place where we have probably a horizontal tangent line somewhere in there. It looks like maybe around 1. It's a closed interval, so we'll have to include the -1 and the +3 when we do our analysis of the critical numbers. And just by looking at the graph from -1, which is right here, to +3, which is right here, I can see that this is going to be an absolute minimum. This is going to be you could call it an absolute maximum, I guess, but it's really a relative maximum here. This would be a relative minimum here, and this will be a relative maximum here, okay? If this was an open interval, then now we're not including these, and we just have an absolute max here and an absolute min here, okay? So get the derivative. What do we do? There should be an f of x here, but there's not, so we put one there because it's fun. F prime of x equals what? 2? Is that it? X to the, we subtract 1 from the exponent and we get -1/3. Rewrite it? Okay. 2 minus 2 over the cube root of x was what you were thinking. Okay. Now what? Okay, set it equal to 0. Now what? Move the 2 over? Because of that minus sign, I like moving this over better. Now everything's positive. So now I have 2 equals 2 over the cube root of x. Now what? Okay, before you do that, I want to address the comment over here. Shouldn't we what? Yeah. You can't have a division by 0, right? So division by 0 automatically gives me a critical number. So x equals 0 is a critical number. Nice job. And notice that that takes care of my sharp point right here. So now I just need to solve for x so that I get the other critical numbers. How do I solve this for x? No. Multiply both sides by the cube root of x. So now we have 2 cube roots of x equals 2. Divide both sides by 2, and we have the cube root of x equals 1. Cube both sides. Cubing undoes the cube root. So we cube both sides, and we get x equals 1. So my other critical number is x equals 1, which it should have been. Here's 1. Here's my critical number. Okay, so if the question is asking, once again, if the question is asking for critical numbers, this is what you do. If the question is asking for what are the relative mins and maxes, then you need ordered pairs. If the question is asking you for tell what the critical numbers are, like are they giving relative mins or maxes, then you make the chart. So we go interval, -1, because it's a closed interval. We have a critical number of 0, we have a critical number of 1, and then we have the other end of the interval. These are x values, and below we're going to go f of x. So now we just substitute in those numbers. We have -1 times 2, which is -2, and then we have -1 to the 2/3, and then times -3. So if you're doing this by hand, let me just go off to the side here. -1 to the 2/3 power. Remember that what that means is the cube root of -1 being squared. Does that make it easier? Okay. So remember, you can take out the root part first and then raise it to the power, or you can take out the power first and then take the root. So we can go -1 squared, which is 1, and then the cube root of 1 is 1. Okay, so we can do that. Times -3, which is -3, and then over here we had -2, so we get -5. When I look at my graph, I do look like I'm at -5, so this is -5. Plug in 0 and we get 0, pretty obvious there. Plug in 1 and we get 2 minus 3 is -1, and then plug in 3. If I plug in 3, I'll get 6 minus 3 times 3 to the 2/3 power. 3 squared is 9. The cube root of 9 is, what number times itself 3 times gives me 9? Something? Is it? Huh. And then times 3. Okay. And then 6 minus that. But negative, right? So negative what? .025. Just call it -0.04 for now. Okay? Sorry, .24. -0.24. So there you go. Those are your values. Now, if you were, like I said, if you were trying to answer some sort of other question that they gave you, we found the extrema. They are here. Okay? For our closed interval, this would be your relative or your absolute maximum. This would be your absolute maximum shared with this one. But in reality, this is a relative maximum, this is a relative minimum. And you can tell that from these values that we found here. This would have to be a max, this would have to be a min. Okay?
Why is 0 and 3 a shared absolute?
Oh, sorry, right. I keep thinking in my head that this is actually 0 right here. So you're right. This is the absolute maximum right here. This is a relative maximum because this one doesn't come up quite as far as this one does over that interval. You're correct. Thanks. Okay? All right, let's have some fun now. Well, we're going to have fun. This is a fun problem. That's right. Nobody's going to die.
No balloon is breaking us down there. So
Nope.
we're not having fun.
Rockets aren't even really being launched anymore. Okay, find the extrema of that function on the interval 0 to 2 pi. And then I give you a little hint here. There's going to be an identity involved. You need to use sine 2x equals cosine x sine x to simplify f prime. That one is the double angle formula that you learned in pre-calculus. Okay, so before we do this problem, let's talk about what we're going to do. Where do we start?
Well, we're finding the extrema, so we're looking for the critical.
Okay, and to find the critical numbers, we have to within the interval. Yeah, that's actually a really good point. We haven't had this issue yet because the functions that I've been giving you before didn't have any extreme values outside of the interval. But this one will because of the fact that it is a trigonometric function. It's going to have repeating values. So we're only going from 0 to 2 pi, and it is a closed interval. So we're going from here to here, which means that we're going to exclude that one right there. But we will be talking about this one, this one, this one, and this one, plus the two endpoints. So now, what is it that we're supposed to do? Yeah. What is it that we're supposed to do? All right, we're going to take the derivative of the function. So we have two terms sitting there. How do we take the derivative of the first one? The first term, 2 sine x.
No, because it's a constant times
Right, it's just a constant times the trig function, so it's just a regular old, yeah. Now the second one, how we're going to have to take that derivative? Okay, now once we take the derivative, what are we going to do?
Then we're going to
Set it equal to 0 and solve for x. Okay, so as long as we have that, then once we solve for x, we'll have all our critical numbers. Okay? And then once we're done with that, then we can finish the problem. So it doesn't matter that I'm giving you a trig function. It's the same process. All right. So let's come up with f prime of x. Good? Okay, I'm going to put the minus. We have to use the chain rule. So maybe off to the side, just because maybe we're struggling a little bit, I'm going to say let u equal 2x. So then u prime equals just 2. Okay? Now we have cosine u. The derivative of cosine u is negative sine u times u prime. So that'll be negative sine u, which is 2x times 2. Is that it? All right, simplify. So we have f prime of x equals, I see the 2 cosine x, and then plus 2 sine 2x. Okay, now use the hint.
Yeah, pull it back around to do it first and then
You could factor out a 2, but let's leave it. The hint is sine 2x, which is what I have right here, is equal to cosine x sine x. So we're going to switch that. Now the reason that I wanted to do that is because of the fact that we had a cosine x sitting here and a sine 2x sitting here. If I were to set that equal to 0, then I'd wind up with cosine on one side and sine 2x on the other side, and that's going to be a big problem. We've done problems like that before, but we had to sit there and really, really think about it pretty hard for a while. And I don't want to have to deal with that. This is going to work out better because now I have a GCF that I can factor out, and then that means I can use the zero product property, and I'm going to be able to find all these critical numbers much easier. So we do set this equal to 0. I'm going to factor out the GCF, which is 2 cosine x, and I'm left with no. And we don't need to worry about that because this is going to be very easy to solve. So how do I solve for x now?
zero product property.
Okay, zero product property, so that gives me and okay. So now on the left side, 2 cosine x, just divide both sides by 2, and I have cosine x equals 0. Cosine is 0 when? Is it? Pretty sure cosine starts high. Pi over 2. So x equals pi over 2 gives me one of them. When else is cosine equal to 0? Is it 3 pi over 2? Look at the graph. Pi over 2, 3 pi over 2.
But what if your, okay, so what if like your graph has some kind of a period change, like how do you tell if there's a period change or not? Does that affect
A phase shift.
phase shift? Oh, yeah.
We're just solving for x here. So we're just saying when is cosine equal to 0? Well, it's pi over 2 and 3 pi over 2. If you had a phase shift, then eventually you'd say, Well, when is cosine equal to 0? And you'd say it's pi over 2, and then you'd have x minus pi over 4 equals pi over 2, and then you solve for x. Over here, we're going to solve for sine x, so we have sine x equals -1. When is sine equal to -1? When? To -1? Pi? Okay, so we have x equals pi. Take a look at the graph. Is that right? No. It's not pi. Pi over 2 sine is at 1, so it's what? No. Wouldn't it be nice if we had a unit circle sitting in front of us? So, I made this one last year. The identity is actually that. There's a 2 there. So that means, that changes things a little bit. That puts a 2 there, which makes that 4. So when I factor out the GCF of 2, there's actually a 2 there. So I need a 2 there, which means this is actually -1/2. So when is sine equal to -1/2? 7 pi over 6 and 11 pi over 6, that's right.
Technically, we were right with 3 pi over 2, but it was wrong.
Yeah, so it helps when you use the right identity, I guess. All right, so take a look at 7 pi over 6. That does seem to be right in that region. 11 pi over 6 is almost 2 pi, and that does seem to be right there. So we've taken care of all of the extrema over that interval. We just also would need to take a look at the endpoints here of the interval. Okay. Those are all the critical numbers. Now what?
Now we can start.
Now we're not done. Make a chart.
And find the y value.
I have x values, and I'm going to have f of x values.
So we can put
What goes first?
2 pi.
This is a closed interval, so we got to include 0.
0.
And then next, pi over 2 is next.
And then no, yeah,
7 pi over 6 is next.
Then 3 pi over 2.
Okay, 3 pi over 2.
And then 1 pi over 6. And then 2 pi.
All right, so now we need to evaluate all these. Try to do them in, let's try to do these in our head. We'll see how we do. We plug 0 in. Sine 0 is 0. Cosine 2 times 0 would be cosine 0, which is 1. So we have 0 minus 1, which gives me, take a look at the graph. Did we do it right? Seems like it. Okay, how about pi over 2? Sine pi over 2 is, no. Sine pi over 2 is 1. So that first term becomes 2. Then we have minus cosine 2 times pi over 2. Well, 2 times pi over 2 is just pi. So cosine pi. Is -1. So that's -1, which becomes +1. 2 plus 1 is 3. Take a look at the graph, and you see that we do have 3. All right, 7 pi over 6. Sine 7 pi over 6. -1/2. All right, see how much easier it is with a unit circle?
Yeah.
-1/2 times 2 would be -1. And then we have minus cosine 2 times 7 pi over 6. So that's 7 pi over 3. Well, that's all the way around the unit circle and then some. Because 6 pi over 3 is 2 pi, so we're at pi over 3. Cosine pi over 3 is what? Well, okay, 1/2. So that's minus 1/2. We had negative 1.5. Negative 3/2. Does it look like it on the graph? Okay. All right, 3 pi over 2. Sine 3 pi over 2. Negative 1 times 2 would be negative 2. So that first term is negative 2. And then we have 2 times 3 pi over 2, so 3 pi. So cosine 3 pi, which is the same as cosine pi, negative 1. So we have what? Is it negative 1? The first term was positive 2. Positive 2 minus 1 is positive 1. The first term was negative 2. So it looks like from the graph we need to wind up adding 1. Cosine 2 pi, cosine of 3 pi is the same as cosine pi. Cosine pi is negative 1. So 2 is negative 2. Minus negative 1 would be negative 2 plus 1, which is negative 1. Okay, 11 pi over 6.
Negative 1/2 times 2, negative 1. 2, so
11 pi over 3 for that, once you multiply it by 2. So what did you get? Don't cheat by looking at the graph. So 11 pi over 3 is the same as, if you go around, okay, so 2 pi over 3. So cosine 2 pi over 3 is what? Negative 1/2. Negative 1/2 becomes positive 1/2. And what did you get from the first term? The first term was a long time ago. Negative 1. So is that negative 1 minus 1/2 or negative 1 plus 1/2? Do we need to write this down? We have sine 11 pi over 6. What's sine 11 pi over 6? Okay, we have negative 1/2 times 2. Okay, now minus, we have cosine 2 times 11 pi over 6, which is 11 pi over 3. 6 pi over 3 would have taken us around, so we're actually not at 2 pi over 3. We're at 5 pi over 3. So it's actually positive 1/2. So minus positive 1/2, which gives us the negative 3/2 that we were looking for. All right, 2 pi, piece of cake. Sine 2 pi is 0. Cosine 2 times 2 pi, cosine 4 pi, same as cosine 2 pi, which is the same as cosine 0, which is what is it? Cosine of 2 pi is the same as cosine 0. Cosine 0 is 1. So we have 0 minus 1, which is negative 1.
Wow, that's okay. So now that we got that chart.
Hey, how about a unit circle somewhere posted on the wall? That'd probably be kind of nice.
You know what? It didn't seem like a good idea. And now I feel like it's necessary.
Yeah, it's pretty necessary.
No, we have it somewhere.
It's in the back room.